Okay, today you're going to be reviewing the volume of prisms and you will be learning about the volume of cylinders. So basically we're just going to want our objectives to be that we are going to find the volume of prisms and cylinders in real life situations. The volume of a solid is the number of cubic units contained in its interior. It's the space inside of it. So volume is measured in cubic units, such as cubic meters. So notice that we'll have the label with an exponent of 3 to show that we are actually calculating something in 3 dimensions. If you look at the volume of a cube, remember a cube has all faces with the same side length. We could calculate the volume by taking the side length and cubing it. The congruence postulate just states that if two polyhedra are congruent, they have the same volume. And the volume addition postulate is when we are taking the volume of a solid as the sum of all its non-overlapping parts. So for instance, you have a cylinder with a cone on top of it. You would be calculating the volume of both of those and adding it together. So finding the volume of a rectangular prism, we look at the dimensions, the length, the width, and the height. The length is 4, the width is 3, and the height is 4 units. So they're showing a unit cube of 1 by 1 by 1 that's going to fill up this box, and how many of those unit cubes will fit into it is basically what we're going to be looking and exploring. So the base of the box is a 5 by 3 dimensional quantity. So this means 5 times 3 is 15 unit cubes would go into the base of that box. We'll be adding 3 more layers of 15 cubes to fill up the box. So that means that there are 4 layers of 15. So 4 times 15 is 60 unit cubes. Because the box is completely filled by the 60 cubes, and each cube has a volume of 1 cubic unit, it follows that the volume of the box is 60 times 1, or 60 cubic units. Notice that in this example that the area of the base, 15 square units, multiplied the height of 4 units, yield the volume of 60 cubic units. So the volume of a prism can be found by multiplying the area of the base by the height. We'll also use this to find the area of a cylinder or even of a triangular prism. It doesn't matter what the shape of the prism is. So here's your basic formula. This is very important. This capital B stands for, so volume is equal to base times height. This capital B, where B is the area of the base. And in a prism, there will be 2 bases that are parallel to each other, okay, so that the edge between them is perpendicular to each base. That is what we call a right prism. H will be the height, or the distance between the 2 bases. So if you're not quite sure what the base is, kind of look to see which 2 faces of the prism have exactly the same shape. So between, like in a triangular prism, there's 2 triangles, and then the lateral faces are all rectangles. So we would call it a triangular prism. When you have the rectangular prisms, all faces are rectangles, so you choose what you want the base to be. In a cylinder, the bases are always the circles, the bases that it can, rest flatly on. So same formula for the cylinder, area of the base times the height. However, note the area of the base of a cylinder is a circle, so the area of a circle is pi r squared times the height. So the formula will just change based on the area of the base. And then of course in a cylinder you would also have to know the radius. So we're going to try out a few examples. If we have this triangular prism, note we said that the base would be the triangular faces, and we also know that the area of a base in this case will be using the formula for a triangle. And change colors here. Okay, so volume equals the area of the base times the height. Area of the base will be 1/2 of the base and height, and notice that's a lowercase b for the base of the triangle, and then this whole thing times the height of the prism. So 1/2, and you have 3 centimeters times 4 centimeters, and all that is going to be times 2 centimeters. And so that's where we get our cubic units. There's always something. Okay. So when you take 3 times 4, you get 12. Half of that is 6. Times 2 will give us 12 centimeters cubed. So make sure that you understand where all those numbers come from. So we took the area of the base, which would be the triangle, and this would be considered, you know, the base, and the height of the triangle. This would be the height of the prism. And then it'll go through it in some words here. Okay. What about our cylinder here? Again, we're using the same formula. Volume equals area of the base times the height. In this case, the area of the base is pi r squared times h. So we have pi times 8, which is the radius, squared, times 6. A lot of times they'll keep pi, like the solution in terms of pi, all the way to the last step. So you could do 64 pi times 6. If you multiply 64 and 6, you'll get 384 pi, and this will be in inches cubed. But for our purposes, we want to go ahead and multiply 3.14. But if you're asked to leave your answer in terms of pi, it just means don't multiply it in. So leave that as the last step if you want to, and you'll get 1,206 and 37/100 inches cubed. And again, it's more likely an approximation because we are approximating pi. So sometimes using the squiggly equal sign to show that you understand that we're using an approximated value of pi. Okay, we'll be using this formula to help us to find, say, a missing side either in a rectangular prism or possibly even in a cylinder. So this kind of has it all spelled out for you with the solution, so we'll just kind of talk through it. So if you have a cube, remember that in a cube, all edges are the same length. It's made up of 6 congruent square faces for a cube. So the volume of a cube would be side length cubed. So if 100 is equal to the volume, 100 feet cubed is equal to the volume, substitute that in for the v. We're saying 100 is equal to x cubed. So now we have to undo cubing x, which would be taking the cube root. And you have a function on your calculator, most likely the second function. And you could put that in. Sometimes you have to put in the x and the y separately, and we can work on the technology part of that in class. So if you take the cube root of 100, you get approximately 4 64/100. And remember that since it's the length of one side, it would be a one-dimensional length. So make sure you take off the cubed for the dimension of feet. So it's 4.64 feet would be equal to x. Same would happen if we were looking at a right cylinder, and we know that the volume is 4,561 meters cubed. We need to find the radius if we're looking for that. The height is given as 12 meters, and then the radius is x. m, and that x stands for the variable of an unknown that we don't know. So we substitute in the values, 4,561 for v. We have pi x squared times 12. So just rearranging them, you have 12 pi x squared. We would have to divide both sides by 12 pi in this case to get x squared by itself. And at this point, you could go ahead and multiply 3.14 times 12, divide 4,561 by that amount. Then you have to take the square root, the positive square root of that to get approximately 11. It would round to the whole number. It would be approximately 11 that the radius would be. So I want you to work through this problem, doing the calculations to make sure that you understand how to get that answer. Okay, and here's that addition postulate. So we're going to find the volume of this puzzle piece shown in cubic units. So I look at this and I kind of think that it's this cube up here and this rectangular part. So if this is 1 and this is 1, right? That, and this is 2 and this whole thing is 3, that makes this part right here, hold on, right here also 1. So it is definitely a 1 by 1 by 1 cube. So we will use, okay, we have volume is equal to the area of the base times the height. And for the cube, we have the area of the base will be 1 length times width times height. So we have 1 unit cubed. And same for our rectangular prism that's on the bottom. The length would be 3 times the width of 1 times the height of that one, 2, which is 6 unit cubed. So we would have 1 plus 6 to give us a total volume of 7 units cubed for the addition of both of them together. Okay, so 7 units cubed. All right, that concludes the notes for today.